Good morning, everybody. Hope everybody had an enjoyable 3-day weekend. If you did, the last time we talked, where we left off was talking about present value of an annuity, and I just want to further the discussion now and talk about the future value of an annuity. So the future value of an annuity is simply you putting money in at a regular rate, at a regular amount, and it accumulates over time, and possibly then when you retire, you have this money you can start drawing on, and then you start drawing down your annuity. Once again, it's like a 401k or something like TIAA, CREF would have, and just what I'm accumulating in real life. So here are the slides for future value of annuity, and this is slide 81, I believe. And here they show you this equation, how you would get the future value of an annuity, and here is your they do it in two steps. Here you have a large amount, right? This would be a single amount of money. Let's say you put $1,000 or $10,000 in, and it was a one payment annuity, and here they show it how to break the present value down into payments. And here's the final equation where you're putting payments at a regular interval, and here's the number of periods, most likely months or years, and here is the interest rate you're getting. Once again, as we've done in the past, this equation, you don't have to worry about this equation because Microsoft Excel has all this built in quite nicely. And there's an example here which I'll show you on slide 82, retirement savings plan annuity. And here's a woman who's 35 years old, and she's decided it's time to save for retirement. In my opinion, that's a little too late. She should have done it 10 years earlier. At the end of each year, so she'll be until she's 35, she'll be saving for 30 years and is going to save $10,000 in a retirement account. And she'll earn 10%. And how much will she have saved at age 35? So if we go here, you can clearly see in the example here, if you go through the math anyway, that it will be $1.645 million at age 65. But just to show you that you can do this in Excel, which I'll bring up right now, quite easily. Here I made 3 input columns, the rate of 10%. Here's the $10,000 a year, as you can see, and here is 30 years. And if I go into this box right here, and I click on f of x, you can see all I had to do, no equations involved, was just put the 3 cells where I had my values in, and didn't have to solve an equation, 3 numbers, and I made the payment minus, right, because it's coming out of your pocket, as you remember, and the answer came out to $1.65 million, roughly $1.65 million right here, as you can see. So here is our final answer, and that matches quite nicely with what they calculated with the equation. All right, so the other point I wanted to make is this is called an ordinary annuity, as you can see what I wrote right there. If she's putting money in at the end of each period. Ordinary annuity means the end of each period. Now, annuity due implies she's putting the money in at the beginning of each period. Let's say she put the money in at the beginning of the year. So you can see there's quite a difference in the amount of money saved if you put the money in earlier, which should make sense to everybody. The earlier you save, the more you get. So she picks up $1.809 million if you put the money in during the beginning of the period, as opposed to $1.644 million if you put it in at the end of the period. So here I'll just show you how I did that. And you can clearly see everything is exactly the same. And the only change I made was in the type box, I put a 1. And as we mentioned earlier, when we talked about present value, rate is the interest rate per period. I'm sorry, hold on. Type is a value representing the timing of payment. Payment at the beginning of the period is 1. payment at the end of the period is 0. So this is called an annuity due, and as you can see, it does accumulate more money. All right, so the other thing I wanted to mention to you was there are slides, and I'll go jump up in the slides where they do talk about using Excel with future value here. And if you just give me, here we are, computing, this is slide 97, computing the future value in Excel. Suppose you plan to invest $20,000 in an account paying 8% interest. How much will you have in the account in 15 years? And you can see they clearly do that here. Here's the numbers they put in. Here's the number of periods. Here's the rate. And here's the present value. Now you'll notice this is not an annuity. Okay? Notice it says that you plan to invest $20,000 in an account, and it's a one-time payment. Okay, it's one time. So you notice in present value they put minus 20,000 and nothing in payment. So it's 15 years, 8%, and minus 20,000, and you'll end up with $63,443. And I'll take a shot at doing that right now. 15, 8, and minus 20,000. So let's go over to here. And there's future value, and 8%, 15 years, and a present value of minus 20,000 gives you 63,000, and I'll say okay, and we get $63,443.38. And if we go back to that PowerPoint slide just for a minute, there it is right there, just what I did. So you see they're even using Excel here to make your life easy. And then here's another problem. Suppose you invest $20,000 in an account paying 8%, and they go on a little more. You plan to withdraw $2,000 at the end of each year for 15 years. How much will be left in the account after 15 years? And here's the 15 years at 8%, and here's the 20,000 you put in, and here is the 2,000 you take out, and they show you're left with $9,139. So this is what's left here. So you see it says we will have $9,139 left in the bank after 15 years. So there's other ways of doing that too. Anyway, you review that, and if there's any questions, just let me know. And here is an example of an annuity with monthly cash flows. And basically, you can pay $20,000 in cash immediately for a car, or you can get a loan that requires you to pay $500 each month for the next 48 months. If the monthly interest rate you earn on cash is 0.5%, which option should you take? And the timeline shows here that the loan is a 48-period annuity for 4 years. And you basically get the amount of money that you would get in interest as an annuity if you if you paid the $500 each month. And you could simply solve the annuity spreadsheet. So you see what it says here. Taking the loan is equivalent to paying $21,290 today. This is a present value problem, by the way, which is costlier than paying cash. So you should pay cash for that car. However, they're not taking into account that you could probably take that cash and possibly invest that cash. So this problem has some problems, in my opinion. Okay. Once again, this is a present value problem. You see they're using the present value function here. All right. So other than that, that's really about it. I will post this, and if you have any questions, please let me know. Alrighty, talk to you later.